Good morning, good afternoon, good evening, depending on where you are watching it from. This is Mega-Hedge Chemistry Forum. In case you are just hearing from us for the very first time, please do well to like, share, and subscribe our videos so that you always have new updates. All right. In today's class, we'll be talking about hydrocarbons. 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 Hydrocarbons, yes. This is the beginning to the study of organic chemistry. Like I said earlier during the introduction, if this is your first time or you are having problems in organic chemistry, please grab your seats and sit back. And make sure you follow us because this lesson is going to be conducted in episodes or in series. This is our series 1. We're going to have series 2, series 3, and so on. So make sure you follow us so that you have the knowledge on all these episodes. So, hydrocarbons. If you hear the word hydrocarbons, the very first thing that will come into your mind is hydrogen and carbon. This is a very big word. Might look very big, might look very big to others. So if I split this compound, this word into two, we are going to have hydro, and we have carbon. What it means is that you have hydrogen, we only have GENF added to become hydrogen, and we have carbon. What if we combine the two of them, we now have hydrocarbon. So by definition, hydrocarbon is an organic compound which is made up or which is composed of two elements. The elements being carbon and hydrogen. So that is the definition of what hydrocarbon is. Like I said, it's a very simple concept. So if we understand what hydrocarbon is, we can now look at the classifications of hydrocarbon. Hydrocarbons is classified into two broad areas. Number one, we have aliphatic part of hydrocarbon and we have aromatic part of hydrocarbons. So hydrocarbon is divided into two. Hydrocarbon is divided into two. We have aliphatic and we have aromatic. So the aliphatic hydrocarbon is further divided into two. Number one is cyclic, and we have acyclic. We have cyclic and acyclic form of hydrocarbons. Then the cyclic form of hydrocarbons are some beautiful compounds, such as we have our cyclopropane, cyclobutanes, and all that. By that, it means that it's going to be in cyclic structure. For example, if we have something like this, this is our cyclopropane. Or some people can as well have something like this. This is our cyclobutane, having 4 sides. There are carbon atoms in each of the sides. So we have our cyclobutane and cyclopropane. These structures are in form of cyclic structure. So in that case, we call it cyclic. If we want to pronounce it, we attach the name cyclo to it. So remember that I said that this is your cyclopropane. I'll explain this. Why is cyclopropane when as series 2 or iso 2? Then this is a cyclobutane. This will still be explained because I know a lot of persons will be having issues with where did you get the butane from, where did you get the propane from. But from my little explanation earlier, you'll be able to understand what I mean by cycle. Now, the next part or the next classification of hydrocarbons is aromatic hydrocarbon. Under aromatic hydrocarbon, we have benzene. We have benzene and other structures that act as what? Benzene, such as we have phenol and others. Then benzene has this structure. This is the structure of benzene. Some people draw it. Some, if you want to show the position of the carbon atoms, which is here, 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 here. If you want to really space out the bonds inside and the number of carbon atoms, you can as well put it like this. Then that is benzene. So it has a molecular formula of C6H6. This is what I mean by having a molecular formula of C6H6. How many carbon atoms are here? We have hydrogen here. We have hydrogen here. Hydrogen bonded here. We have hydrogen here. Hydrogen, hydrogen. So if you count how many carbon atoms? 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. How many hydrogen atoms? 1, 2, 3, 4, 5, 6. Now, this is for benzene. Like I said, the only aromatic hydrocarbon that is classified, that I'm using here as an example of an aromatic hydrocarbon is benzene. Like I said, there are other members of the compounds that behave like that falls under this aromatic hydrocarbons. I've mentioned phenols too. Okay, so with this, we have come to the end of today's class. In our next class or in our next video, we will be showing you how to get the other members of the acyclic hydrocarbons. Like I mentioned the straight chain, I mentioned the condensed, and I mentioned the branch. In our next series, we'll be talking about acyclic hydrocarbons in full. All right. So thank you very much for joining us today. We look forward to seeing you in our next class. Thank you so much.